chit-chat some more, huh? Now, there is something I snuck in on you guys on that with outliers thing. There are a couple ways to deal with outliers. One way is to get rid of them. Just take them out, measure them, quantify them as outliers, and throw them away. That is one way to deal with them. I think it's a heavy-handed approach. You ever heard the phrase, one way to cure a headache is to cut your head off? Hey, gets the job done, a little heavy-handed. So, one way to deal with outliers is to throw them away. My personal favorite thing to do with outliers is to look at them more carefully and see if something's going on. Like maybe, for example, when I collected my data, I inadvertently mixed in a variable that I wasn't accounting for. Like maybe I mixed in land prices, large land parcels with homes, in which case I got a few large land, like 500 acres in Northwest Bend, Skyline Forest, for example. $22 million. But I inadvertently called that house price, so it got mixed in the data set. So sometimes outliers can be just misrepresentations of what you're looking for. More on that later too. These weren't. These were all coded as houses, homes. Not bare land, but homes. So another way to deal with them is to say that everything, because it's Bend, everything's just kind of weird in Bend, leave them in, but do what's called a trimmed mean. Now a trimmed mean is fun. It's like, it's an average. It's a mean, it's an average. But what you do is, you take the top and bottom 5% of values out and throw them away, and re-average what's left, the middle 90%. So what you would essentially do is you take away quite a few of those, if not all of those goofy $8.8 million or whatever they are houses. But you'd also lose these guys down here. And the idea being, if there are any goofy values that are pulling the data too far to one side, you'd then remove them and focus more on the center values. And you can see that that actually did work a little bit in this case. If I do a 5% trimmed mean, it's $350,000, which is below this. It's still above the actual non-outlier data, which means there obviously were more outliers than lowball figures over here, like what JT said. But it's definitely a more fair estimate than including all the outliers in it. So you'd move your finger from here to here, the plate of cookies. Not all the way down to here, which would be this plate of cookies, but not quite as far as the 400,000. So a trimmed mean, we'll come back to that in this class. It's a great tool that's used occasionally, generally when you have goofy outlier type data. But the big lesson, the big takeaway from this is, when you have skewed data, you generally don't want to use the average, because the average can be misrepresentative of what's actually going on. If you've got a bunch of data down here with a tail tailing off this way, the average is going to go follow that tail and try to end up. It's trying to balance. I mean, the average is a balance point. It's trying very hard to balance. The average is the only one of the three measures that actually uses the values of the data points in its calculation. I want to say that a couple more times because that's important to differentiate. There are three measures of center that we talked about: the mean, the median, and the mode. The mode doesn't even look down here at the beginning. It looks up here and finds the highest bar. So it's not referring to these numbers until we have to talk about what the highest bar is. But do you see how that these values down here aren't used in the computation at all? Doesn't use the actual values of the house. It just looks for the highest bar. So the values down here are irrelevant for the mode. It's just looking for the highest bar. The median doesn't use those values either. For the most part, it's just doing positional. Lowest, highest, next lowest, next highest, next lowest, next highest. Where you end up is just a function of where the stuff is laid out. The only computation that actually uses each individual value in the computation is the average. So if you stack on a bunch of high values, necessarily all those individual high values are going to drive that average up, probably artificially. So that's why I use care when using averages with skewed data. Because you can get an inflated average. Aaron mentioned at the break, is that why they don't talk about, or you mentioned, sometimes they talk about average salaries. Be careful talking about average anything. If you know it's bell-shaped or roughly bell-shaped, then go ahead. We just saw it. When you have bell-shaped data, the average is about the same as the median, same as the mode. But if you just have an average, it can be kind of meaningless. You know, it's like saying the average human being has one breast. It's because we're half guys and half girls. I mean, it's perfectly true and completely useless. I mean, right? I mean, think about it that way. It doesn't make any sense. You can make an average with any data set. It doesn't mean it's meaningful. So you got to be careful using averages, especially when all you have is an average without a visual of the data. Ask for the other ones too and see if they're close in value. There's actually ways to measure skewness. We'll talk about it briefly, maybe. We'll see. We might talk about it in a quiz or something. But there's a way to measure skewness, because of course the question is, you're calling this skewed, Sean. How can I tell that's not a bell curve? Other than the fact that we talked about it and decided it wasn't. Well, there's ways to quantifiably measure it too. And we'll talk about those as we go through the course. They revolve on other measures as well. But the biggest thing is just kind of look at it. Does that look, would you call that a bell curve if you had a choice to call it a bell curve? Some of you might say yes. Some of you might say it's bell curved enough, that's totally fine. Some of you might say, nah, it's got too long of a tail over there. I guarantee if I put the outliers back in, nobody would call it bell-shaped. You'd say, oh, okay, now it's too much like a leaning bell curve. It got squished. Fair? So just, again, statistics often raises more questions than it answers. And I'll ask you questions sometimes on assessments. I would say, do you think that data is bell-shaped enough? And half of you will say yes, and half of you will say no, and that will be totally fine. I'm ready for those. Yeah!
So the latest thing on the news is
good.
Women on average make 77 cents less than men.
77 cents on the dollar. They make 23 cents less, 23% less than men. I've heard the same thing. There's a cookie day at COCC soon where they sell, depending on your gender, guys will pay $1 and girls will pay 75 cents because of that. It's not, I mean, it's funny when you hear it out loud, but it's depressing as hell if it's actually true. I mean, you know, the 29th Amendment, I believe, correct, was women's voting rights. I'm going on my memory here, which is probably pretty bad. 19th, I had the 9 right. Is it, are you up to 29 yet? We're not even there yet, are we? But regardless, that was 100 years ago, correct? 100 years ago, and if that's still even close to being true, I don't know, I've never seen the numbers on it. Never seen the numbers on it. I don't know, it's not true at COCC, because I run the numbers at COCC myself. But that's not at COCC, that's not nationwide.
But there's too many variables. What kind of work are they doing? Are all those women working?
Have they been accounted for in the study? Have you seen? I don't know. Maybe they've controlled for those.
All we see is the final results.
Of course, and which is, thank you, which is always dangerous. Always, are you comparing apples to apples? Right? Are you comparing apples to apples? Sometimes like this Obamacare thing is very, very simple to look at. Although it's not very, very simple to look at. If you go and dive deeper into that data set, there's definitely some questions that are answered there too. But yeah, the important thing is to go dive and look. Go dive and look. You're going to get lost in the murk. That's okay. Get lost in the murk. The fact that it's murky makes you question some of the results. Although I don't question that one. I'd like to see the study myself. I don't question it. But yeah, that's in the news right now, and it's pretty. You'll see that COCC. See that COCC soon. Thank you. Tell me your name again.
Shaylee.
Shaylee, thank you, thank you. I plead ignorant on that one just because my nose has been in other data sets.
I just called BS on it.
They have a poster about it too, like in the library.
Really?
Is there any data? Are there like governmental data sets tied to it? An annual report done?
I'll look.
Please do, if you don't mind, and send me anything you find on it. That'd be awesome, Aaron. Thank you. I love diving in. We make a quiz out of it. Make a quiz out of that. I'd love to. Love to. I mean, that's the whole point. This is what makes it real. Because it's right in front of you every single time. You guys have like 80 quizzes opportunities by the time it's last. All right, here we go. I'm going to turn this one around on you. This happened in Math 95 a few years ago. I gave 63 students an exam. Their average grade was a 71. Their median grade was a 78. The minimum grade was no lower than 50. And the maximum grade was no higher than 100. What I want you guys to do is, I want you to draw a graph of this. What you think the distribution looked like. I want you to sketch it. Here's a set of axes. I made you a blank set of axes. A blank set of axes. I want you guys to draw a histogram in here. I already set up the ranges for you. 10s, 10 at a time, 50, 60, 60, 70, 70, 80, 80, 90, 90, 100. Draw me a histogram that shows 63 total students. There are 63 altogether. You can approximate, you don't have to get exactly 63, you get close to 63. The average, that's a Greek letter mu, which is the population average symbol. We'll come back and talk about him later. I can call this a population because we're only talking about my Math 95 students and I have them all. The average was 71, the median was 78. So draw me a graph where the average is 71 and the median is 78. I'll leave the blank up there. We'll turn the camera off, give you guys some time to work on it.